Hi students, good morning. Welcome to Go Vidya. As we all are aware that Andhra Pradesh government approved for the recruitment of AP Transco, GENCO and DISCOM for the post of AE and AEE electrical. So as part of preparation for the students, we started this online session for the previous year question solvation. As we know that any competitive exam you can succeed if and only if you are we are completely practiced, well prepared with the previous year questions. From the previous year questions, what you can understand is how will be the question pattern. That means what type of questions we may get in the upcoming exams, and we have some awareness about what are the most important topics of each subject, where we need to stress and where we need to leave the concepts. So this and all you can get idea by solving the previous year questions. Am I audible? Hi students. Am I audible? Can you please text over the comment box? Hello students. Am I audible? Please text out the comment box. Hi students. Am I audible? Okay, thank you. See, so in this session, what we are going to learn is we are going to solve the previous year questions. Previous year's questions we may get from any website and all, but inside view of the question. That means how the point of view, how we need to see a question for exam point of view. We are going to explain in this session. I think hopefully this will be helpful for your preparation. Okay, if you want any doubts or clarifications, you can chat over the comment box. I can reply for that. Okay, so in today's session I would like to start with the first subject as transformers. So we know that most of the questions from any AP Transco, GENCO or DISCOM, most of the questions will come from machines and power systems. I think this will cover around 50 to 60% of the syllabus. So remaining subjects questions will come. It will vary based on the exam pattern. Almost 50 to 60% questions will come from the electrical machines and power systems. If you observe any previous questions, you can come to know that. Okay, so I would like to start with the electrical machines, that too from transformers. We'll see the first question. See, any question, if most of the students will get panic when they see the problem. So this we need to avoid. Why? Because now the competition is very high. So in order to meet that competition, we need to be well prepared with all type of questions. Okay, So some students may be comfortable with the conceptual questions, some students may be comfortable with the problematic, but we need to balance both. Okay, so even if it is a problem, since we are having a time of less than 1 minute, so the examiner also will consider that point. So most of the questions we can solve within a minute. Okay, so whenever you see a problem, don't get panic, just read the question once. From after reading the question, just you note down that means from which subject it came and from which concept, what are the formulas you remember regarding to that concept, and apply the given data in the formula and you get the answer. These are the simple steps we need to follow. For any question, if you follow this pattern, definitely you will get succeeded. Okay, coming to the question, two transformers with leakage impedance Z1 and Z2 are connected in parallel. The ratio of load shared will be. If you see the question, the examiner is focusing on the parallel operation of the transformer. Okay, first we will note down what is the concept, on which concept this question came. This is parallel operation of transformer. Okay, this is the concept the examiner is asking. Okay, so we need to remember any formula we are having related to parallel operation of the transformer. So we know that the load sharing will be depends on the impedance. So you can write it as load sharing SA, let it a transformer, SL will be the total load, then it will be like this, ZB by ZA plus ZB. I consider two transformers A and B, where ZB and ZA are the impedances of the transformer A and transformer B, where SL is the total load and SA is the load shared by the transformer A. Okay, so similarly SB is equal to SL into ZA by ZA plus ZB. Okay, this is the formula we remembered from the parallel operation of the transformer. Okay, up to this it is fine. Next, what we need to see is the given data. What is the given data? Actually, if you see that, one thing we need to remember when you are solving a problems on this load sharing. Okay, this given problem may be simple, but in future we need to see how the impedance is given, whether it is given in per unit or in ohmic value. So if it is a ohmic value, we can directly substitute the given value into this formula and we can get the load share of the each transformer. Okay, so what we need to remember before submitting the given data to formula, what is that? The main where most of the students getting mistake is here only. That means impedance is given in either ohmic value or per unit value. We need to first check the units, whether it is given in ohmic or per unit value. For suppose if they given in ohmic value, we can directly substitute the value to this formula and we can get the load share from each transformer. But if they given in per unit value, we need to convert into common base. So we might have studied in power systems that conversion per unit to ohmic value and ohmic to per unit value. So that we will discuss in the upcoming subjects. So for time being, just remember, if it is a ohmic value, you can substitute directly. If it is a per unit value, we need to convert to the ohmic value and then we need to substitute. Okay. So for a given problem, no need of this much calculations. Just we will see we can take it as a proportional. That means SA is directly proportional to ZB. Okay, whereas SB is directly proportional to ZA. Okay, so they are asking the ratio of SA by SB. So the ratio will be ZB by JDA. Okay. So since it is a ratio, the proportionality constant can be same, so we can get cancel out. Okay, so we can write like this. So no need of any calculations here. It is very simple thing. Okay, so the thing what we need to remember is most of the questions given are very simple values they will give. That means for easy calculation purpose. Why? Because we are having very less time to solve the question. So most of the examinations they won't allow the calculator also. So most of the problems we need to do in hand calculations only. So that's why if you see the values, ZB is given as 0.05 plus J zero point 0.2 and Z1 is given as 0.1 plus J zero point 0.4. Okay. So what you can write it as SA by SB is equal to 0.05 plus J 0.02 divided by 0.1 plus J 0.04. Okay. So the simple thing is we can write the denominator as, we can take a 2 as common, then it will come 0.05 plus J 0.02. Okay, so from after calculation it will come as SA by SB is equal to 1 by 2. This is the answer. Clear? So we can see the options which is suitable for our answer. If you see here, our answer is option B. Okay, so I would like to convey that. So in our any problems given, most of the problems will come from machines and power systems only. Okay, so other subjects also problems will come, that will be on very basic questions will be there. Most of the students will feel difficulty while solving the problems in especially electrical machines. In our sessions we are going to clear all your doubts and we will provide very simple way to solve the questions, and we can get succeeded in our upcoming competitive exams. Okay, any doubt in this question? Please chat over the comment box. Hi students, please. Okay, I think it is clear for all. We'll see the next question. So the next question is, in a transformer all day efficiency is. So first of all we need to know about the meaning of all day efficiency. Okay, so if you know that meaning, then only you can go for the options. No, so what is all day efficiency? The term all day efficiency or energy efficiency, both are same. Okay, all day efficiency or energy efficiency equal to output energy divided by input energy. Okay, this is the formula of all day efficiency. Okay, so what they are asking, it is a comparison with the full load efficiency. Okay, full load efficiency. So in general this all day efficiency will depends on duty cycle, will depends on duty cycle. depends on duty cycle. What is duty cycle? Duty cycle is nothing but it is depend how much power flow happened for a particular hour. You might have known that we are having a 24 hours in a day. So each hour how much power flow is happened. That means power into time for first hour plus power into time for the second hour and so on up to power into time for the 24th hour. This is the duty cycle. Okay. So the energy, the all the efficiency depends on the duty cycle. Sometimes the power flow may be high, sometimes the power flow may be less. So in all over, the load also will be load setting may be done. That means sometimes the power flow will be zero also. So what I mean to say from this is, so all the efficiency or energy efficiency depends on the duty cycle. So the total efficiency may be less than the full load efficiency. Okay, is always less than the full load efficiency. Why? Because the efficiency at full load means the power flow will be constant. Okay, the power flow will be constant, but here in energy efficiency the power flow will change according to the duty cycle. So all day efficiency always less than the full load efficiency. Okay, our option is C. Okay, is it clear? So it is a conceptual question. So just if you know the definition of all day efficiency, you can easily solve this question. I think it's clear. If any doubt, please comment over the chat box. Okay, we'll move on to the next question. Okay, the next question is about auto transformer. Okay, so we need to follow the steps. Oh, don't forget. First we see the question. What the question is given: a 25 kVA 2000 by 200 volt a 2-winding transformer is connected as shown in figure. Okay, so they given the connection diagram also. The full load kVA of the connection is. So if they given the connection diagram, we don't need to worry anything. If they didn't given the connection diagram, we need to check the polarity and all. Okay, we'll follow the steps. First of all, concept. From which concept this question came? The question is came from the concept of auto transformer. First, the concept is auto transformer. These type of questions are repeated many times in GATE and other competitive exams. Okay. So whenever the questions came on auto transformer, especially about the kVA, if they given any polarities, that means they will tell it as a series additive, series subtractive. That means the secondary voltage higher side or step down or step up. You can make the auto transformer both step up and step down. Okay, so based on that given data, we need to understand that. If you see here in the given data, if you see, they given the circuit diagram. From the second circuit diagram, it is V2, this is V1. So V2 is greater than V1, so it is a step up transformer. So one thing what we need to understand, in a transformer, kVA in primary equal to the kVA in secondary. This thing you should not forget. Okay, this is common. Okay, kVA in primary is equal to kVA in secondary. So what they are asking, full load kVA of the connection. So for kVA calculation, what we need? V2 into I2 we need. So from this V2 they given, I2 also they given. Okay, so from the given circuit diagram, V2 is 2200 and I2 is 1 to 5. If you multiply this, how much it will come? Please calculate and chat over the comment box. How much it will come? 2200 into 125. Okay, so it will come around 275 kVA. Okay, understand? Option is B. Is it clear? Okay, we will move on to the next question. Okay, next question. First we will read out the question, then we will come to the solution. The given question is, a single phase transformer has resistance and reactance of 0.2 per unit and 0.6 per unit respectively. Its per unit voltage regulation at 0.8 power factor lagging would be. Okay, by reading the question, first we need to come to know on which concept the question came. The concept is voltage regulation of transformer. It is regarding voltage regulation. So since it is a problem, we might have clearly known the formula. Okay, the formula for voltage regulation of a transformer is percentage regulation is equal to percentage R cos pi plus percentage X sin pi. This is the formula. From this formula, first of all, we need to know the terms. Okay, a percentage, sometimes they will give the values in percentage, sometimes they will give the values in per unit also. In this case, we can substitute directly. Actually here percentage values are equal to the per unit values. Okay, so if they given directly percentage are in per unit, you can directly substitute in the formula and you can get the answer. If they given in ohmic values, we need to calculate the per unit values, but that will be very lengthy process. Most of the times they will give the values either in percentage or in per unit. Don't get confused over that. If they given in percentage or per unit, you can directly substitute the values in the given our formula. Okay, we will note down the given data. What is the given data? If you see given data, if you see resistance, okay, resistance is given as 0.2 per unit, reactance is given as 0.6 per unit, power factor cos pi, okay, cos pi is 0.8 lagging. This is important. Actually the formula will in general plus or minus, okay, plus or minus will be there, and we need to focus on the power factor. Okay, why I am stressing over it is the sign will change for based on the power factor. If it is a lagging power factor, the sign will be positive. If it is a leading power factor, the sign will be negative. Okay, so in a given data, the power factor is lagging, and we need to calculate the sign terms. Okay, for sin pi is equal to be 0.6, because sometimes these values we need to remember, otherwise we have to calculate from the formula. Okay, as we know, cos square pi plus sin square pi is equal to 1. From this formula you can calculate if required. Okay, so the given data we can substitute to our formula, then percentage regulation we will get it as 0.2 into cos pi. Cos pi is 0.8. As the power factor is given as lagging, we need to consider positive. If it is a leading power factor, we need to consider here it is negative. Okay, so reactance is 0.6 into 0.6. Okay, 0.16 plus 0.36. It will come around 0.52. Clear, students? Any doubt? Please chat over the comment box. Okay, this is the answer of the question. Our option is A. Is it clear? Only one precaution we need to take while solving this type of question is whether the power factor given in lagging or leading. If you focus on these two terms, we can get the answer very easily. Most of the students are going to do mistake here only. Okay, clear? Okay, we'll move on to the next question. Okay, we'll read out the question. The question is, a transformer has maximum efficiency at 3/4 of full load. The ratio of iron losses and full load copper losses is. Okay, so first of we'll note down the concept is about. What is the concept given? The concept is about efficiency. So that too maximum efficiency. Okay, the concept is about maximum efficiency. What is the formula we remembered for maximum efficiency? Iron losses need to equal to the copper losses. That is at the full load. Okay, iron losses need to be equal to the copper losses. So they are asking the ratio of iron losses to copper losses. What we need to find out? Iron losses to copper losses are the load of 3/4 of full load. 3/4 of full load. We know that iron losses are constant losses. It won't vary with the loads. Okay, so our iron losses will be constant. It won't vary. But whereas copper losses, we know that copper losses is equal to the I square into R. I is here full load. Okay, so the copper losses are directly proportional to the square of the current. So if load is varying, load current will vary. If load current varies, copper losses also will get vary. Okay, so what we need to do? We need to calculate the copper losses first. Copper losses we need to calculate. We know that copper loss at any fraction of load, that means let's take it as x. Copper losses at any fraction of load is equal to the x square into copper losses at full load. Okay, copper losses at full load. So the fraction of load of full load, at what fraction of load they are asking? 3/4. So our x is going to be 3/4, and you can substitute, and our full load copper loss will be, let it as WC. Okay, so we know that at maximum efficiency, iron losses equal to the copper losses. Okay, from this calculation our copper losses will be 9/16 into WC. So the ratio will be, what they are asking? Iron losses to copper losses. So iron losses to copper losses equal to the 9/16. Is it clear? The option is C. Okay, so in this question, what many of the students where they are doing mistake is calculation of the copper losses. Okay, always we need to remember that the copper losses are going to be vary with the load. So if the load is changing, we need to calculate the copper losses particular to the fraction of load. Okay, so from this you can understand that the maximum efficiency you can calculate like this. Okay, any doubts, please chat over the comment box. Hope all are fine with my explanation. Okay, we'll go to the next question. Okay, the question is about a three-phase transformer. Okay, by seeing the diagram we can understand that it is a three-phase transformer. Okay, we'll read out the question what they are asking. The following connection of a three single-phase transformer bank results in. Okay, so what they are telling, three single-phase transformer banks they taken and they connected as like given in the figure. Okay, so whenever these type of problems came, first we need to redraw the circuit once. Redraw the circuit and make the phasor representation. So most of the questions we can solve simply by representing phasor representation. Okay. A B C. Okay, let's take it as V at an angle 0. This one take it as V at an angle 120. Let's take it as a three-phase balance system. So what will come? If it is a three-phase balance system, first phase at 0 means next will be 120 degrees lagging, and next will be 240 degrees lagging. Okay. So the primary side we may make up the phasor representation. We'll see the secondary side also. Okay. So how the secondary side is connected? So all points are connected at one point. Make it as a neutral. So whatever they given, we'll mark it A1 B1, A2 B2, and C1 C2. Okay. This is the given diagram. So what will happen? The total voltage, the number of turns are going to be divided at center. So we know that voltage is directly proportional to the number of turns. If the turns are divided, voltage is also going to be divided. So V by 2 and V by 2. Okay. So our what about phase angle? Let us take it as V by 2 at an angle 0 degrees means it is going to be completely opposite. That means it is going to be 180 degrees. Okay. So it is going to be 180 degrees. Why? Because the polarity will change. So the polarity will change to the second half. Similarly, here what will happen? Here V by 2 at an angle minus 120 will be the first phasor. Second phasor V by 2 minus 120 plus 180. Okay. From where this 120 came? Already that A phase to B phase, the place displacement 120 degrees will be there. Here again we splitted the total winding into two parts. From this you can get. Okay. Next, coming to the third phasor, V by 2 at an angle minus 240. This will be the first phasor, and second phasor is V by 2 at an angle minus 240 plus 180. Okay. Clear? So we will write the phasors individually. VA1N. VA1N I am taking as a phase voltage. Okay. VA12 with respect to neutral. V by 2 at an angle 0. This will be A2. This will be B1. Okay. VA2N equal to V by 2 at an angle 180 degrees. VB1N equal to V by 2 at an angle minus 120. VB2 equal to V by 2 minus 120 plus 180, it is around 60 degrees. Okay. So VC1N equal to V by 2 at an angle minus 240. VC2N equal to V by 2 at an angle minus 60 degrees. Okay. So we will write the phasor diagram. From this we can understand how many phases are there in the secondary side. So first we know, take reference as VA1N. The B phase is going to be lagged by 120 degrees. It will be VB1N. Next the C phase VC1N. Okay, this is clear. Okay, I taken the first group of phasors and written the phasor diagram. Now we can see from the representation VA1 and VA2 are 180 degrees apart. Okay, similarly VB1 and VB2 are 180 degrees apart. Similarly VC1 and VC2 are 180 degrees apart. I get from this only. Okay, you might have seen the values here. No, these two are 180 degrees apart. From there I calculated. Okay, so after seeing the secondary phasors diagram, how many phases we are getting? 1, 2, 3, 4, 5, 6. Okay, the total phasors are in secondary side are 6. Okay, the primary side is 3. So it is a 3 phase to 6 phase conversion transformer. Our option is D. Is it clear? Okay, it is very simple question. By seeing the diagram, most of the people may get confused. Okay, how this connected and all. No need to worry. Okay, just write down the phasor representations from primary side and secondary side. Then you can easily and you can get the answer. Okay, so sometimes these type of questions may come. That time it will trickle you. Okay, that may trouble you. So that type of questions, the approach is very important. How we are approaching towards the question is very important. So if your approach is good, within a short time you can answer this question. So don't panic over this by seeing the question. My sincere suggestion is, whenever the question looks difficult, the answer will be very easy. This is the fund of the competitive exams. Okay, we'll go to the next question. What is the question given? A transformer can have regulation closer to 0. Okay, what is they are asking? Actually it is regulation means indirectly voltage regulation. Okay, it is about voltage regulation. So I told you the 4 steps. First we will write what is the concept. This concept is about voltage regulation of transformer. Voltage regulation of transformer. Okay, so what we understand, so we need to understand 2 things whenever voltage regulation problem came. One is formula. We already solved the previous question just 2 minutes back. Okay, that is the formula, and how to solve that I already explained. The second concept is the voltage regulation curve. Okay, the voltage regulation curve is most important in transformer. Okay, this side is lagging side, this side is leading side. Okay, voltage regulation versus power factor. This is the power factor versus voltage regulation curve. Okay, this curve is very important. So what type of questions we are getting here most of the times is zero power factor. Zero voltage regulation. At what power factor we will going to get the zero voltage regulation? If you see here, whenever the power factor is leading, then only there is a chance of zero voltage regulation. Zero voltage regulation. One more question may come from this curve is maximum voltage regulation. When you can get it is at lagging power factor. Okay, the theory question we need to remember 2 points. One is when the voltage regulation of transformer is going to be 0. The when means at what power factor the voltage regulation of transformer is going to be 0, as well as at what power factor the voltage regulation of a transformer is going to be maximum. Okay, if you understand this, you can solve the question. Okay, very simple question. It is repeated many times in our competitive exams. Is it clear? If you have any doubt, please chat over the comment box. Hopefully my explanation is understanding to the all. Okay, if we have any doubt or any problem while solving the question, please chat over the comment box. I will explain one more time so that your concept is clear. My final motto is our students need to be clear about the concept. When you are strong at basic concepts, definitely you will get succeeded. Okay, so we are there here to help you. You can see the our helpline number of Govidya. You can contact anytime. Okay. Okay, we will move on to the next question. What is the given question? The full load copper loss of a transformer is 1600 watts. At half load copper loss will be. So this question is repeated last time. In previous question also we solved the same kind of problem. Okay, we read out the question. Now we understood that the concept is related to, first we need to note down what is the concept. Copper losses of transformer. Okay, copper loss of the transformer. What we need to find out? Copper loss at, they given copper loss at full load, and we need to calculate copper loss at half load. As we already explained, the copper loss at any load, at any fraction of load x equal to x square into copper loss at full load. Okay, so where x is the fraction of full load. At what fraction they are asking? From the given data, what fraction they are asking? X is equal to half load, that means 1 by 2. They given full load copper losses as 1600 watts. Okay, so our copper losses at half full load equal to x square, that means 1 by 2 whole square into full load copper loss given as 1600, so 1 by 4 into 1600, it is going to be around 400 watts. Okay, so therefore copper losses at half full load will be 400 watts. Okay, our option is A. Is it clear? Hope you understand the problem. Okay, so in this question most of the students may do mistake is that a fraction, how to calculate the fraction. Okay, if you are clear about that fraction, then it is very easy. We know that formula and you can substitute the given data, you can get the answer. Okay, we will move on to the next question. Okay, the given question is about a 400 by 110 volts single phase transformer has primary resistance of 0.03 ohms and secondary resistance of 0.02 ohm. Okay, so its iron losses at normal input are 150 watts and the secondary current at which the maximum efficiency will occur. Okay, what they are asking? Secondary current. Okay, it will be a little lengthy question, but if your approach is good, you can get the answer within a short period of time. Okay, first of all we need to understand what is the concept of this question. The concept is calculating of maximum efficiency. Okay, we need to understand that at maximum efficiency iron losses equal to the copper losses. So iron losses are constant at any point of load. Okay, they are asking load current. At what load current the efficiency is going to be maximum. Okay, our copper losses will depends on the current I to M, secondary current they are asking, into R02, the resistance shifted to secondary side. Okay, so in order to calculate this, let's take it as equation 1. From equation 1 we can calculate copper losses. As iron losses given, we can calculate the copper losses. From that we can calculate I2. For that we need to calculate one more term, R02. What is R02? Resistance shifted towards secondary side of the transformer. What is the formula for that? R02 equal to R2 secondary side resistance plus R1 dash. What is R1 dash? Primary resistance shifted towards secondary side. How we are going to calculate? How we are going to calculate V2 by V1 whole square into R1. Just substitute the given values. What is the R2 given? 0.02. What is the voltage? 110 by 440 whole square. What is the R1 given? 0.03. What will come? 0.02 plus. Please calculate and tell. It will be 1 by 4 whole square into 0.03. How much it will come? It will come around 0.021875. This is our R02. Okay, so we need to calculate the I2M. Okay, what is copper losses is equal to I2M square into R02. We got the R02, and from equation 1 we can write as iron losses equal to copper losses. That equal to what the given iron losses? How much? Just read out from the question. The iron losses given is 150 watts. Okay, so our copper losses also need to be 150 watts to get the maximum efficiency. So let us take it as equation 2. From 1 and 2, what we can write? I square I2m square R02 equal to 150. I2 square m is equal to 150 divided by R02. Okay, from I2m is equal to square root of 150 divided by R02. R02 how much you got? 0.0218. Zero point 0218. After solving this, how much you got? Please comment over the chat box. It will come around 82.94 amperes. Okay, is it clear? Okay, our option will be around C. So our option is going to match with C. Okay, clear? So just see the question and remember the concept what you studied regarding that concept. Okay, and follow the formulas and apply the given data. You can get the answer very easily. Okay, where most of the people are going to do mistake this type of question is, so the calculation of R02, how they are going to calculate the R02? They directly substitute the second resistance here and they will calculate. That is not correct. Why? Because our copper losses are a combined of both primary plus secondary. We have to shift either the resistance towards primary side or towards secondary side. Then only you can get the total copper losses. That is the main important thing. Most of the students are going to do mistake here only. Okay, so if you are clear about that concept, then you can solve the question is very easy. Okay, So by seeing the question, it may be lengthy, but if you remember the basic principle, all are basic things only. That means shifting of our primary resistance, secondary resistance, from this formula you got, and at maximum efficiency it is iron loss is equal to copper losses. Okay, copper losses equal to the this after shifting the total resistance to one side, we can get the copper losses like this. Okay, just three basic principles if you know, you can solve the question very easily. So as I already told, most of the students are going to do the mistake in calculation of copper losses. Okay, that we need to be aware, that we need to be little carefully, we need to note down into the given data. Is it clear? If you have any doubt, please chat over the comment box. I am ready to hear explain. Okay, if you want any support, you can call our support line, our support mobile number given in the screen. Okay, we are ready to help you. Okay, coming to the next question, which of the following transformer have the secondary open circuit while the primary is energized? I think here some small mistake is there. What is that mistake is, which of the following transformers should not have the, should not, what it means, when primary is energized, secondary should not open. What type of transformer it is? Okay, what type of transformer it is? We need to see the options given. Power transformer, we know that power transformer, if primary is once primary is energized, then only voltage will get induced, then only flux will develop, the flux will travel to secondary side, then secondary voltage will inject, afterwards only current will develop. Okay, so if secondary side open also, power transfer may not get any affected. Okay, it will act as a, for power transformer it will act as a no load condition only. Okay, if secondary is open circuit, it will act as a no load condition only. So next, potential transformer. Actually this potential transformer and current transformers are called instrument transformers. These are using in high voltage substations to step down the voltage and current parameters. So in potential transformer, what is they are telling? Secondary is open. Okay, since it is converting only voltage, that means higher voltage to high voltage to low voltage, it is also like a step down transformer, and it may not affect. It is also act as a transformer with no load. But whereas current transformer is important. Why current transformer should not open? We need to understand the basic concept about current transformer. What is the current transformer? Current transformer is stepping down high current to low current. In general, it will be in the ratio of 1000 to 1 ampere or 5 ampere, like this. This is the ideal ratio. That means 1000 amperes is going to convert into 1 amps and 5 amps. Okay, so what we need to understand here is, so if the secondary is open means current will be 0 in the secondary side, but primary side we are having a current, okay, 1000 amps. This 1000 amps will flow in the winding, it will induce the voltage. The induced voltage will be very high. There is no counterpart to balance this voltage. In general transformer, there will be a counterpart to balance the primary voltage. But here, since the current is 0, no voltage will develop in the secondary side. So since it is a very high voltage, this may damage the insulation of the transformer. Okay, transformer insulation may get damaged. Okay, so this is also very important question. Most of the competitive exams it got repeated. Okay, just if you understand the concept, you can easily answer that. And the second thing is given as auto transformer. Auto transformer is, in general, it is nothing but a power transformer only. Okay, you might have studied in our theory. Power transformer and auto transformer both are same. That working principle may be different, but finally the overall picture will be same for both power transformer and auto transformer. So our option is C. Is it clear? If you have any doubt, please comment over the chat box. Okay. So if you have any doubt, about how to prepare and you need any coaching, you can contact our coaching given in here. This is our number, this is our mobile number of Govidya. You can contact. We are ready to help you. We are happy, indeed we are happy to help to the students. Okay, so we'll see the next question. The next question is about an isolation transformer has primary to secondary turns ratio is. Okay, so in general the transformers we are we might have seen as step up transformer, step down and isolation transformer. These are the major classification of the different transformers. Okay, step up transformer means secondary voltage will be greater than the primary voltage, that means N2 is greater than N1. Step down is secondary voltage is less than the primary voltage, N2 less than N1. In isolation transformer, V2 equal to V1, N2 equal to N1. That means in isolation transformer the turns ratio is going to be equal, primary turns equal to the secondary turns. Okay, our option is A. But why isolation, where isolation transformer is going to be used? That is the question. You might have known step up transformer, step down transformer, where we are going to use. In step up transformer generally we are using at generating stations. Okay, generating stations, what they are doing, they may be generated at a very low voltage, 11 kV to 25 kV like that, and to transmit that low voltage to far ends, they are going to step up the voltage to reduce the transmission losses. Okay, so that step up transformer in general you are going to see in generating stations. The step down transformer is it is near about distribution. Okay, near about distribution. This step down we are going to see is distribution. Why? Because at high voltage we are transmitting due to reduce the transmission losses, but for using of that power we need at a low voltage scale. That means at 3 phase means 415 volts and single phase means 230 volts. Okay, where isolation transformer will come. In general, isolation transformers are used in the industrial lightings, industrial lighting loads. Why specifically this means to isolate the other circuit from the lighting loads. What will happen if any in olden days most of the lights are in this sodium vapor lamps and mercury vapor lamps they are going to use for industrial lightings. So those lights will draw very high power and power factor will be less, as well as if voltage fluctuations will be high. This lighting load should not affect the other auxiliary system of the system. Okay, so in order to electrically isolate the other system with the lighting loads, we are going to use the isolation transformer. Just it is a purpose for isolating other loads from the lighting loads. Okay, is it clear? Lighting transformers, isolation transformer also called as lighting transformers. These are going to used in the industrial loads. Okay, is it clear? Hope everybody understand my explanation. If you have any doubt, please comment over the chat box. Okay, this session will be continued tomorrow morning 6 a.m. So please inform to your friends and join over the live stream. So we are happy to help you, all the students who are going to prepare for Transco and GENCO. Okay, please support us. Our contact number is given here. If you have any support, either coaching, test series, okay, you can contact this number and we are ready to serve you. Okay, So our session will continue tomorrow 6 a.m. Please inform to your friend. Please make the participation more. It will be a little encouragement